Welcome to Bruce Hurwitz Presents Meet the Experts. I'm your host, Bruce Hurwitz of Hurwitz Strategic Staffing. You can find us on the web at hsstaffing.com. I hope you'll consider us for all your staffing, career counseling, and professional writing needs. I'm delighted that I will be joined momentarily by Dr. Jaya Viswanathan. We will be discussing neuroscience and society. Meet the Experts is sponsored by P&K CPAs. P&K is a full-service accounting firm. They provide accounting and consulting services to businesses ranging from startups to small and mid-cap companies to nonprofits, as well as high-net-worth individuals. Contact them today for a free consultation at info@pk-cpas.com or call them at 973-882-8810. They will be happy to be of service. And I must apologize for messing up your last name.
No, not at all. Thank you so much, Bruce. It's really a pleasure to be here and chat with you. I've been looking forward to this chat for the last few weeks. So thank you so much for the opportunity to share my story and be here.
Well, it is my pleasure. Would you take a moment or two and introduce yourself to our viewers?
Absolutely. So thank you again for the opportunity to be here. So my name is Jaya Viswanathan. I am a career neuroscientist. So what that means is I've spent most of my life in school. So after my engineering, I did a master's in neuroscience, followed by a doctorate in cognitive neuroscience. And then I did a postdoctoral fellowship in neurophysiology, where I was recording from awake behaving animals and trying to figure out how their brains were processing information. And I can get into that in a little bit. After which, I currently now work at the National Institute on Aging in the National Institutes of Health in the United States. I'm a contractor, and I work in what's called program development, where we're trying to support and achieve the research goals of the national plan to address Alzheimer's. And in my spare time, recently, I've written, illustrated, and published a children's neuroscience book called Baby Senses. So that's what it looks like. And it's an introduction to neuroscience to people of all ages, but also children, trying to link the why to the how. So why did brains evolve to do something? And then linking that to how brains actually solve various problems in nature. So that's me in a nutshell. Thanks again for having me. Yeah.
My pleasure. I was going to ask you something else, but I'm going to continue for what you were saying. The brain is an analytical tool, not a storage tool. So,
okay.
For the only data that's really stored in the brain is what we need to do what we need to do. Everything else we store in books, on computers. Cavemen would draw their drawings on the wall. We've always had external memory storage units. Today it's called hard drives. Now, as I understand it, we only use something like 10% of our brains.
Yeah, so I think that's one of those myths about the brain. And it's interesting to hear you call it as an analytical tool. To me, one of the main things that our brain does, in fact, is actually act as an interface between us and the environment. And that can be an external environment, right? So how we navigate the world. Of course, actions fall into it, but then a little bit of storage and memory is involved for things like even small things like when a doorbell rings, you need to have the memory of that being the doorbell and not your cell phone. And so day-to-day items, so there's that level of information storage as well as retrieval, and then also our internal environment. So like when we're feeling hungry, when we're feeling nauseous, whatever. So there's some kind of internal environment sensing that happens. So often the brain is actually kind of like the control center interfacing between all of these and then affecting our actions through, again, this interfacing center.
Thank you.
At least that's how I understand it,
That's
right? So of course, like I think
but we don't use 100% of our brains. That's why when someone suffers a brain injury,
right,
if they've forgotten how to walk, then new neural pathways can be formed, new cells activated so that they can relearn how to.
Yes. So that is really something that goes into plasticity and redundancies that are built into the brain, right? So often we find that, and I'm going to maybe use this example to kind of highlight that best. But a great example is face recognition, right? So like humans are very social beings, and it has been to our benefit that we form solid societies and interact with each other. And so we've developed a very sophisticated individual recognition system for other faces. Now, fast forward to current day, and there are people who are experts in cars. Now, obviously, the brain did not evolve to recognize cars because cars were not around when human beings evolved, right? But then what the brain does in those, and there have been numerous neuroimaging studies conducted to kind of look into things like that. And what the brain does is often hijacks the same pathways that's already put in place to most efficiently do those computations, right? But then in the case of things like brain injury, because there are multiple kind of neurons and computational capabilities in the brain, there are ways to get to the same output, but perhaps it's no longer the most efficient, but it doesn't mean you can't get there, right? So there's a lot of plasticity, but there's also a lot of redundancy built into the system where you might, in case of injury, kind of recruit these other areas to do those functions that previously you didn't because maybe they were more metabolically expensive, maybe they were going to be longer, more time consuming, and so on.
I knew a 3-year-old
Mm-hmm.
in Israel
Mm-hmm.
who was fluent pretty much
Okay.
in English,
Yeah.
parents, Hebrew, it was Israel,
Yeah.
and Yiddish for his grandparents.
Okay. Wonderful.
I knew he was either 4 or 5-year-old who knew every car on the road, literally the make, the model, the year.
Absolutely.
Now, children are very aggravating, especially when you're trying to
Okay.
learn a foreign language and they get it
Yeah.
like a sponge.
Yep.
So you've been talking about evolution.
Yeah.
But a child's brain and it has to evolve to become an adult brain. But it would, in a way, I mean, it's a historic. If you look at it through
absolutely
perspective of time, it's a split second.
Yeah.
But to go from 3 to 30,
Mm-hmm.
the brain has to evolve. But it would seem that in some things, the less evolved brain better than the more evolved brain.
Right. So, I mean, this is a great point. I think it's one of those things where we're really built to learn because human infants are born pretty helpless. And a lot of things are learned through things like statistical learning, which is just repetition. And as a field, I think we're still, as a field in neuroscience, we're still trying to understand the principles by which human brains learn. But one thing we do know is that neurons undergo a process called pruning, where things that are inherently more important get solidified and wired together, and then things that are less important don't. And so there's some level of pruning. And for example, one of the experiments that they did with language, speaking of language as an example, are listening to so there were babies in Japan who were played sounds in English and Japanese, and then babies in America who were played sounds in Japanese and English. And after 6 months old, if they had not been exposed to any Japanese at all, they were not able to differentiate the sound between R and L, right? And so that was a solid experiment that they conducted. And what that shows us is that before the age of 6 months, brains are paying attention to everything, right? And one of the benefits of that age as well is that not a lot of these are reaching consciousness. So it's not necessarily reaching a conscious threshold of experience, which is why we don't remember it. But it's kind of like being able to pay attention to everything and then kind of figuring out over time in critical periods of development what is really important and what needs to be paid attention to as we grow up. And it doesn't mean that as adults we're not able to pick up new languages. It's just going to take longer. Right? Like I don't want to create that kind of misunderstanding in what I'm saying. It's about, like, again, it comes back to plasticity. We'll be able to get there. It'll just be lower because as adults, we typically have more demands on our consciousness. We have top-down directives, right? Like, I don't know, like maybe you need a job to pay rent, and you have all of these other things that can override just sitting back and paying passively attention to everything, and then slowly accumulating information about what's important and needs to be stored. So that, I would say, is like the real big difference between infant brains and adult brains. And there's some evidence to this, like if you and it's called statistical learning, even in adults, if you play meaningless noise, either in the visual screen or auditorily, if you just have, and then you ask people to tap, so you freeze a certain segment and then you repeat it multiple times embedded in the stream of white noise, and you ask people to pay attention, they might not get it immediately, but they'll be able to pick up that there's some kind of rhythm in it, repeating, and tap along with it or something. And so infants are going to get that right away because what their brains are doing are just primed for repetition, primed for any clue as to this is an important stimulus, like this is the face of my mother versus this is just a picture on the wall, right? So those kinds of differences, they need to pick up right away, and a lot of their brain energy spent on figuring those kinds of things out.
I doubt you would know this. I don't think you're old enough. But in the 1960s,
Okay, not old enough.
Was passed. Okay.
Okay.
I guess correctly. A law was passed. It was an easy guess. 1960s, a law was passed that what movie studios were doing was illegal. What were they doing? Or they made it illegal. After every, I don't remember, 10, 2,500 pictures on a film, they would insert a picture of something that was sold at the snack bar.
Okay.
It wouldn't bother you watching the movie because you didn't really see it, but you did see it. Your brain picked up on it.
Yep.
And that's one of the reasons why it cost what it cost to go to the movies, because they were conning you into being hungry.
Yep. Yeah.
The brain does pick up, but it's also, you'll probably know, I don't know what it's called. I don't remember what it's called, but there are microscopic facial movements that we do not see consciously. but our subconscious or unconscious, I never know what the difference is, picks it up. And that's why we can say, the minute I saw her, I didn't like her. Now, it may be that once you get to speak to the person, your second impression, which is the first impression that you're aware of, changes your mind. Happens all the time. But this goes to what you're saying, and I think to our topic, which of course is neuroscience and society. So how does the subconscious, unconscious mind within the framework of neuroscience impact how we relate to society?
That's a great question. First of all, thank you for that question. I love that question. So I'm going to dig into that a little bit. So we can take a step back and look at what is consciousness in a second as well. But more importantly, I think there are lots of animals that have been evolutionarily very successful without a large prefrontal cortex. A great example are crocodilians, right? So they are very, very evolutionarily old, and a lot of their behaviors are extremely instinctual, and they've been very successful. They've not gone extinct with the dinosaurs. They didn't, and they're still very successful predators today. So if you look at the human brain anatomically, of course, the prefrontal cortex, this nice mammalian cortex, all of that are the newest evolutionarily. And yes, they have contributed to us having some very unique abilities that other species don't. But if you look at strictly survival, you can argue how necessary are those parts for survival as a species, right? So one thing so all of this is leading up to the fact that often, and definitely in humans, the inputs that are going from like the oldest part of our brain, which is the brainstem, to our midbrain, and then the newest part of our brain, which is our cortex, are much stronger and more in number than vice versa.
So the brain evolved from the back to the front?
That's how it develops, but it's basically the frontal cortex is like a layer that developed on top of an existing brainstem. The brainstem is inside, so it connects to our spinal cord. It's it's not necessarily the back of the brain is still cortex. It's a visual cortex, but it's like the innermost part of our brain, and that controls things like our basic eye movements, breathing, things like that. So very basic, and of course things like fear response, amygdala, our hunger response. So a lot of our basic life functions are tied to our brainstem and midbrain that are kind of the gatekeepers sometimes of the sensory information that comes into our brain for action. So what ends up happening is that when there's a signal of threat, even if it's a perceived threat that you were talking about, like when you look at someone and you instinctually don't like them or fear them or have an aversive reaction. So part of that could also be smell, right? So not just like conscious smell, but like biological smells that might be threatening to your biology for whatever reason. And so a lot of those signals end up being very strong. And so it'll take, as you said, like a second impression and more time to possibly overcome those signals because of top-down effort, which is not impossible. It's certainly possible to overcome those, and certainly as human beings, we can control our emotions. That's not what I'm saying, but it takes a little bit of extra effort to kind of override our bottom-up responses, as they're called, through our top-down responses.
You keep on saying the human brain.
Yeah.
I had friends, a lot of friends who had
Mm-hmm.
children,
Okay.
and on occasion they'd ask me to babysit.
Okay.
And either you're going to agree because you know this and you've seen it, or you won't understand it because you have to
Okay.
understand it.
Okay.
Dogs make the best babysitters.
Okay.
A dog can calm a crying baby.
Sure.
A dog understands why a baby is crying,
Okay.
and they will play with the baby.
Sure.
Protect the baby, they'll play with the baby. And in this case, I was this child's first babysitter.
Okay.
She knew me, and for the purpose of this story, the dog knew me.
Mm-hmm.
And the three of us got along very well.
Mm-hmm.
And when she was, I don't know, about 10 months old and she could sit up, I decided I was going to teach her colors.
Okay.
And I put out, blocks, and I'd say, this is blue, this is red, this is green. Give me the green one.
Mm-hmm.
And after a while, the dog would push the green one. The dog learned quicker than she
Absolutely.
did, which absolutely shocked me.
Yeah.
Then I was doing a search. As you know, I'm a recruiter for a director of research for a Parkinson's disease nonprofit.
Okay.
And I found a neuroscientist who had done his doctorate on guppy fish.
Okay.
And I said to him, what's the connection between guppies and our Parkinson's? And he said that the eye movements of the guppy stimulate the brain just as the loss of that
Mm-hmm.
is identical to the loss of brain functions in somebody with Parkinson's. And
Okay.
I probably have that wrong, except for the basic thing that there is a correlation between the brain of the guppy and the brain of a person. And for
Okay.
my example, the learning abilities of a dog versus a child, and the dog was probably a year old. So
Okay.
7 human years, if you will.
Yeah.
There are a lot of solutions that can be found in nature.
Absolutely.
The
Yep.
solution to global warming is a tree. It's that simple.
Sure.
Trees clean the air.
Yep.
You mentioned, if I'm not mistaken, that you're working on Alzheimer's.
Yep.
Which is near and dear to my heart because my favorite jobs were working in 2 different nursing homes.
Okay.
And I was fascinated going to the Alzheimer's floors, wards, whatever you want.
Mm-hmm.
What can we learn from nature? Or have we found something in nature where animals, I don't think it could be plants, but animals are combating serious diseases such as Alzheimer's?
Absolutely. And I mean, I think so. You've touched on something that's very dear to my heart. And actually, in my book as well, I don't talk about humans. In fact, I talk about animals who've evolved to do things better than humans have in many ways. And so, yes, the short answer to your question is yes. A great example are tardigrades. I'm not sure if I'm pronouncing that right,
I
but
have no
they're
idea.
these, yeah, so they're these tiny microorganisms. They look very alien. And they have basically this ability to survive extreme desiccation. And so people are studying their protein structures to kind of figure out, are there drugs that we can isolate that are going to be protective of their brains and their nervous systems because they survive these extreme climates? And then can we make those into drugs, for example? And so there's all kinds of, you can look at things like chaperones, which are these proteins that help fold other proteins into the correct shape. So in any disorder where there's protein misfolding, you can think of if you can target chaperones to refold the badly folded protein into its correct form, you might be able to fix the underlying biological problem of that disease. And so one thing people are looking at, for example, are chaperones in long-lived species versus short-lived species. There are some species who live as long or longer than humans. Elephants live very long. There are some giant turtles that live very long. So there's certainly things in nature that have and continue to inspire medicine and innovation. Another great example, so that I actually touch upon in my book as well, are pit snakes. I think they're amazing. Pit snakes have a pit organ that are able to thermally image their environment. And so they're nocturnal, and so instead of seeing things in color and light, they're able to actually map out heat signatures, and so they can see when there's a mouse versus when there's a rock of the identical size around them. And so what some scientists are using that is to like biologically inspire design of nanorobots that are heat seeking. And so the reason to do that is that tumor tissues are metabolically more active than the surrounding regular tissue. And if you can find a way to precisely target the warmer tissues because they're dividing rapidly, you can really target medications there. You can target ablations to those tissues in particular without harming any of the surrounding tissues, right? And so absolutely, I think every day we're in science, we're finding inspiration from the natural world because nature in many animals and also plants has solved some, as you said, some of these problems very, very efficiently, and we can learn a lot from that.
Now, what I've learned is that when I start coughing,
Okay.
I got to take more water. Now, this really pains me, but we're almost out of time.
Okay.
So what I want to do is share your contact information, and I'll let people see us. And before I let you go, I have one final question.
Absolutely.
Is there anything that I have not asked you that you wish I had asked you? And if I had asked you, what would you have said?
Oh, perfect. Okay. So I would just add on actually a context for what we've been talking about, which is also neurodiversity. So I think, so we've talked about natural diversity and how these plants and animals have evolved, but I also, one of the reasons I wrote this book for children is also because I wanted, with all these weird animals, I wanted kids to pick it up and feel like being different can be a source of superpower for your brain, because our brains are amazing. They've really evolved to do things even at our lowest moment, to solve problems and do things while we're not even thinking about it. And so the only thing I would add is, again, this more bit of context is that neurodiversity is precious, and diversity in nature is precious, and we should really work as a community together to preserve that.
There was one thing I wanted to ask. I forgot, just remembered it. What is neuro art? You had mentioned that in the application you filled out.
Absolutely. So neuro art is the practice or recent trends of making paintings or art out of the beauty in neural systems. And so art in biology has been documented for hundreds of years, where you can look at the symmetry or beauty of a shell and then draw it and be inspired to art through biological forms. But for a long time, neuroscientific images were just in textbooks. They were inaccessible beyond a paywall. They've been just used for educational purposes in terms of like, this cell does this or this cell does that. But neuroart is really taking that and creating art out of it, creating inspiration out of it, bringing the artistic community into science to build collaborations around it. So if I may, I'm happy to show a couple of examples. So like, this is a
Well,
painting of a retina.
let me stop the share so it'll be seen.
Okay.
Now you can do it.
Yeah. So this is a painting of a retina, for example. So it's still got all the biological forms intact, but that's a more artistic rendering of it. And that's an artistic rendering of an olfactory bulb and so on.
Okay.
Yeah.
Well, I'll put your contact information back up.
Okay.
I want to thank you profusely. This has been fascinating. I learned a lot. I'm sure our viewers did. And on behalf of all of us, thank you.
Thank you again for the opportunity, Bruce. It's been a real pleasure chatting with you today.
Pleasure's been mine. I'm Bruce Hurwitz. Thank you for watching. And as always, please stay focused on success.